Okay, so we're going to talk about function operations today and something specifically called composite functions. We've done function operations a little bit at this point. So like if f of x was equal to x plus 3 and g of x was 2x plus 7, and I asked you what f of x plus g of x was, what would you do?
Combine the like terms.
Yeah. And if I said, so this would be f of x plus g of x would be x plus 3 plus 2x plus 7.
Right, so what would that be? 3x?
3x plus 10. That's what those two functions added together is, right? And if I made it minus,
Still combine like terms and subtract.
it would be minus 2x plus 7. Don't forget the parenthesis because we're going to distribute the negative 1. So this is x plus 3 minus 2x minus 7 becomes negative x minus 4. Right? Okay. And if we did f of g times g, or f of x times g of x, we would take x plus 3 times 2x plus 7 and distribute. Right? And f of x divided by g of x, we would take x plus 3 divided by 2x plus 7. That's it. Okay, so an added thing to this is in this section, you're going to be asked to find the domain and range of things. Okay, and so if I have, let's say this, negative x minus 4, and I asked you what the domain and range are. Well, what does that graph look like? Don't tell me specifically, but what is the shape of it? Negative x minus 4. It's a line, right? It's not a parabola. It's not one of those exponential functions we've been working on. It's just a line. What's the domain and range of a line? Yeah, but what is the domain and range of a line? Any line. What's its domain and range? Yeah, all real numbers, right? Because the line goes on forever, and there's no place that line can't exist, right? So when you get an equation like this where you've got a line, well, the domain and range go on forever. What about this? Well, if I distribute 2x squared plus 7x plus 6x plus 21, which is 2x squared plus 13x plus 21. Doesn't ask me to solve it, just wants me to define what that is. What's the shape of this? It's a parabola. You guys are so good. It's a parabola. What's the domain and range of a parabola? Okay, so if I were to graph this, let's just graph it. 2x squared plus 13x plus 21. There it is. What's the domain and range? Domain is negative infinity to positive infinity. I agree. But the range never doesn't go below this point, does it? So you've got to find the vertex. The value of that vertex, negative 0.125 is the y. So negative 0.125 is your low, and positive infinity is it goes to positive infinity, yeah. So be careful. On parabolas, your x, if it opens up or down, your x values are negative infinity to infinity. Your y values, you've got to find the vertex. Okay, and if you want to do it by graphing on the graphing calculator, that's fine with me. Because I'm testing more in this section on your knowledge of what domain and range are than how to graph a parabola. We've already tested you on that.
Over and over and over.
Okay, so we're good there. Now, the last piece of the four functions, if you add, subtract, multiply, divide, is when we got division here, x plus 3 over 2x plus 7. We don't really know what that function looks like. You haven't learned how to graph those. And you hopefully will get there, but I don't know. We're behind. It's called a rational function. Okay? But one thing you would be able to tell me is what its domain and range are. Where can this function not exist? No, it could be negative. Think about what happens when the denominator is 0. When the denominator is 0, what is it? It's undefined. It's not 0. When you divide something by 0, it's undefined. It's not 0. Okay? So this function cannot exist where the denominator is 0. So to find where it can't exist, what you do is you set the denominator equal to 0. So I know when x is negative 7/2, can't exist. It can exist any other x value. So my actual domain here is going to be negative infinity to negative 7/2. I can't include negative 7/2 because it can't exist there. Union with negative 7/2 to infinity. The only number it can't be is negative 7/2. Okay, so to find the domain on rational functions, you just set the denominator to 0, figure out what x is, and that's the value it can't be. And it can be any other value. Okay, what do you think the domain of let's make it minus 1. How would I figure the domain of this? What can't it be? Generally, not the number, but what can't it be? Can't be negative under the radical, right? So I need to figure out where this is equal to 0, and it's going to be any other number less than that, right? Okay, so when x is 1/2, this is 0. When x is less than 1/2, this whole thing is going to be negative. So I know it can't be anything less than 1/2. So my domain, and it can include 1/2 because 0 is okay under there, but it can't be less than that. Yeah, there's my domain. Okay, so this section you're going to be asked to find the domain of functions. Okay, and I just want to review that to make sure you understand what they're looking for. Okay, what would be interesting is if the square root of 2x minus 1 is in the denominator, it also can't be 0, right? So all that would change here is that. Because when it's 1/2, it's 0, and it can't be that. So it just makes it not include 1/2 now instead of include 1/2 in the numerator. Okay, it takes a little practice, but you're going to have to understand how to find the domain of these functions.
So I understand how you're doing it.
Mm-hmm.
I understand how to do it, but like I'm confused on the 0 part.
Well, if I have this in the numerator, if it's 1/2, if x is 1/2, that's 0. And I can take the square root of 0. So I can include 1/2 in my answer. But if it's in the denominator, it can't be 0. Huh?
Why can't it be 0?
Because it can be 0 here. Because anything divided by 0 is undefined. Right? When we talked about the last one we did, it couldn't be 0 in the denominator because it's undefined. Yep. So we just had to add a little bit of a caveat. It not only couldn't be 0, but it couldn't be negative, which is why I can't include 1/2 now.
So that's why you said it equal to 0, so it's not 0 in the denominator. Okay. I understand.
Yeah, it's almost, I mean, I know it can't be 0, so I'm going to figure out when it is 0 what that value is, and then I know it can't be that number. Okay. All right, so the last piece in this section is something called function composition. So let's use the same two functions here. Okay, function composition. You will see it two different ways, and it means the same thing. That's not an O, that's a little circle.
It means the same thing.
This means f of g of x. Okay? Usually what goes in here in these parentheses is what your input number is. Normally we just see it as x. But now it's saying instead of x, we want you to put g of x in. So you look at the function f, because that's what's first. Okay, and everywhere there's an x, you're going to put g of x in. That's what f of g of x means. Okay, so what happens here is it becomes 2x plus 7 plus 3, which is 2x plus 10. F of g of x is 2x plus 10.
That's the same thing when we did when we were adding them, right?
No, when we added them, we got 3x plus 10. So what I'm going to do, whatever is in the parentheses is what I replace x with in the original. Okay? Students get really confused on this, and it's not that hard if you think through. This number is the input of the function. Okay? And the input of the function normally is just x.
So it'd be the same thing if we would
So if I did g of f of x,
plug in x
I'd plug x plus 3 in for x. 2 times x plus 3 plus 7, which is 2x plus 6 plus 7, which is 2x plus 13. So g of f of x is 2x plus 13. F of g of x is 2x plus 10. It's not bad once you wrap your head around what they're asking. Okay, let's do one that's maybe a little more complicated. Let's see here. F of x is x plus 5. No, I want to do square root of x minus 8. G of x is 1/2 x squared. So, f of g of x. What do you think?
It's going to be x 1 over 2x squared into the x position.
Okay.
F of x. So the square root of 1.
Good. Let's do g of f of x.
It would be 1/2 times x minus 8 squared. Turn square root.
Which is 1/2 times x minus 8, right?
Can you solve 1? Can you simplify the square root of 1/2 x?
No.
I mean, I know that the 8 is negative, but again,
Nope, you can't just take the square root of this and the square root of this. Okay, so this is f of g of x. This is g of f of x. Okay, so what I want you to do on this one is tell me its domain.
on which one?
The f of g of x. Tell me its domain.
Is its domain?
What would I do to find it? What can't it be? This function under the radical can't be negative. So I'm going to figure out where it's 0,
Equal to 0.
and then whatever that number is, it's going to be less than that number, because that'll make it negative, because anything less than 0 is negative. So I'm going to take 1/2 x squared minus 8, set it equal to 0. Multiply by 2. So it can't be positive 4 and it can't be negative 4.
So it can be
That's where it's equal to 0. Okay? So what I want to show you is if I graph this, this is not a negative 1/2 x squared. This is just a 1/2 x squared. Yep. I'm trying to figure out where this is negative, right? Everybody see that? I'm trying to figure out where this is negative. So I'm going to just graph this. I'm not going to graph the root. I'm just going to graph this, because where it's negative is where it goes below the x-axis, right? So I have 1/2 squared minus 8. We found the zeros for negative 4, right? Where is this parabola negative? It's negative here, 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 all the way everywhere below the x-axis. It's negative, right? So that function, the square root of this, cannot be any number between negative 4 and 4. Because any number less than negative 4 is positive, greater than negative 4 is positive, and that's great, but between negative 4 and 4, the function's negative, and a negative can't be under the radical. Yes, so I would write this as my domain can be negative 4 and 4, because the square root of 0 is still 0. That's something I can do. So it's going to include negative 4. That's not my domain. That's where my domain can't be. Negative infinity to negative 4, union with 4 to infinity. That's where my domain is. Because between negative 4 and 4, my function's negative, and you can't have a negative under the radical. So graphing these sometimes really helps you figure out where the domain is. You are including. Yeah, because it can be negative 4. The square root of 0 is still 0. It can't be it can't be between negative 4. Okay? What about the domain of this one? G of f of x. This can be negative. It's just a line. All real numbers. Yeah. A line has all real numbers as its domain. Okay? Doing the composites for students, once you figure it out, isn't too bad. Finding the domain is probably the hardest part about this section. Okay? All right. That's it. It's not open.